Picture this. Every day, Earth is quietly showered with tiny specks of dust from the cosmos. Not the kind of dust you sweep off your shelves, but microscopic particles from the far reaches of the universe. These are the universe's tiny messengers, carrying secrets from exploding stars, ancient asteroids, and cometary trails. You might think they're insignificant, but these specks could hold the key to some of Earth's most explosive geological events. Let's dive into the wild connection between cosmic dust and the fiery depths of our planet, where supervolcanoes lurk, ready to reshape the world. You probably don't notice it, but Earth is bombarded by cosmic dust all the time. Scientists estimate that around 40,000 tons of extraterrestrial material falls onto our planet every year. That's not a typo. 40,000 tons. Most of it is so tiny, it's invisible to the naked eye, burning up in the atmosphere or settling quietly onto the surface. These particles, often smaller than a grain of sand, come from the remnants of stars that exploded millions of years ago, asteroids that collided in the chaos of the early solar system, or comets that shed their icy tails as they swing by the sun. It's like the universe is constantly sprinkling us with stardust. But here's the kicker. This isn't just a modern phenomenon. Researchers have found traces of cosmic dust in some of Earth's oldest rocks, dating back billions of years. In 2019, a team studying ancient Australian rocks discovered tiny grains of extraterrestrial material locked away like time capsules. These grains, called pre-solar grains, predate our solar system and hint that cosmic dust has been raining down on Earth since its earliest days. This constant influx isn't just a cool fact. It might be messing with our planet in ways we were only starting to understand. So where does all this cosmic dust come from? Imagine the universe as a giant recycling plant. Stars live, die, and explode in spectacular supernova, blasting their guts across space. Those guts, elements like carbon, silicon, and iron, condense into tiny particles that drift through the cosmos. Some of these particles get caught in the gravitational pull of asteroids or comets, which act like cosmic delivery trucks. When these objects pass near Earth or break apart, they shed dust that eventually finds its way to us. Comets are especially messy. As they orbit the sun, they heat up and release streams of dust and gas, creating those beautiful tails we see in the night sky. Some of that dust ends up on Earth. Asteroids, too, contribute when they collide or erode over eons. Even distant galaxies play a role. Dust from their ancient stellar explosions can travel across the universe, carried by cosmic winds. It's a mind-boggling thought. The speck of dust under your shoe might have been born in a star that died before Earth even existed. Now let's get to the juicy part. How does this cosmic dust connect to Earth's supervolcanoes? Supervolcanoes aren't your average volcanoes. These are the heavyweights, capable of eruptions so massive they can alter global climate and wipe out entire ecosystems. Think Yellowstone, Toba, or Taupo. Their power comes from the intense heat and pressure deep within Earth's mantle, where molten rock, or magma, builds up until it can't be contained. But what if cosmic dust is secretly stoking that fire? Scientists have started exploring whether these tiny extraterrestrial particles could influence Earth's internal heat. The idea sounds wild, but it's rooted in some fascinating science. Cosmic dust often contains radioactive isotopes, elements like uranium and thorium, that release heat as they decay. When these particles settle into Earth's crust or get subducted into the mantle through tectonic processes, they could act like tiny heaters, adding to the planet's geothermal energy. This isn't just speculation. Studies of meteorites, which are larger cousins of cosmic dust, show they're packed with these heat-generating isotopes. Over billions of years, the slow accumulation of cosmic dust in Earth's crust could contribute to the heat that drives volcanic activity. It's like throwing a few extra logs onto a fire, except this fire is the molten core of our planet, and the logs are bits of ancient stardust. Supervolcanoes are rare, but their eruptions are catastrophic. The Toba eruption, about 74,000 years ago, spewed enough ash to blanket the planet and trigger a volcanic winter that may have pushed early humans to the brink of extinction. Yellowstone's last major eruption, 640,000 years ago, left a caldera so big you could fit a small country inside it. These events are driven by massive magma chambers, fueled by Earth's internal heat. But could cosmic dust be a hidden ingredient in this explosive recipe? Here's how it might work. When cosmic dust falls to Earth, it doesn't just sit on the surface. Over time, tectonic plates can drag it deep into the planet through subduction, where one plate slides beneath another. These plates carry the dust and its radioactive isotopes into the mantle, where temperatures and pressures are extreme. As the isotopes decay, they release heat, which could help melt rock into magma, or increase the pressure in existing magma chambers. It's like turning up the dial on a pressure cooker. In 2021, a study in the journal Nature Geoscience suggested that extraterrestrial material could play a role in Earth's geothermal budget. The researchers found that even small amounts of radioactive isotopes from cosmic sources could contribute significantly to the heat-driving mantle convection, the process that moves tectonic plates and fuels volcanoes. While the study didn't focus on supervolcanoes specifically, it's not a big leap to think that this extra heat could tip the scales in regions already primed for massive eruptions. Here's where things get really intriguing. Could cosmic dust act as a trigger for supervolcano eruptions? Imagine a region like Yellowstone, where a massive magma chamber is already simmering, waiting for the right conditions to blow. The slow buildup of heat from cosmic dust's radioactive decay might not cause an eruption on its own, but it could push the system closer to the edge. Then something else, a tectonic shift, a sudden influx of new dust from a nearby asteroid impact, could be the final straw. This idea isn't as far-fetched as it sounds. Scientists know that external events like asteroid impacts can influence volcanic activity. The Chicxulub impact, which wiped out the dinosaurs 66 million years ago, is thought to have triggered massive volcanic eruptions in what's now India, known as the Deccan Traps. Cosmic dust, while subtler, could work in a similar way over longer timescales, quietly adding energy to Earth's geological systems until they reach a breaking point. The clues are all around us, locked in Earth's rocks. Geologists have found cosmic dust particles, called micrometeorites, in ancient sediments and volcanic ash layers. These particles are often rich in rare elements, like iridium, that are more common in extraterrestrial material than in Earth's crust. In some cases, spikes in iridium levels have been linked to periods of intense volcanic activity, hinting at a connection. For example, studies of volcanic rocks from the Siberian Traps, a massive volcanic event tied to a mass extinction 252 million years ago, have shown traces of extraterrestrial material, suggesting that cosmic dust may have played a role in that catastrophe. But it's not just about the past. Scientists are now using advanced techniques like mass spectrometry to analyze cosmic dust in modern volcanic deposits. By studying the chemical signatures of these particles, they can trace their origins and estimate how much extraterrestrial material is cycling through Earth's geological systems. The numbers are small. Cosmic dust makes up less than 0.01% of Earth's crust, but its impact could be outsized, especially when it comes to heat generation. So, why should you care about a bunch of space dust messing with Earth's insides? For one, supervolcanoes are a serious threat. A major eruption today could disrupt global agriculture, block sunlight for years, and cause widespread economic chaos. Understanding what drives these eruptions, whether it's Earth's own heat or a cosmic assist, could help us predict when and where they might happen. That's not just academic curiosity. It's about saving lives. Plus, this connection reminds us how deeply our planet is tied to the universe. Earth isn't an isolated ball of rock floating in space. It's part of a cosmic dance shaped by forces far beyond our atmosphere. Every speck of dust that falls from the sky is a reminder that we were made of star stuff, and that same star stuff might be stirring the fiery heart of our planet. The story of cosmic dust and supervolcanoes is still unfolding. Scientists are only beginning to piece together how these tiny particles might influence Earth's geological engine. Future research could involve drilling into volcanic regions to hunt for more extraterrestrial material or using computer models to simulate how cosmic dust affects mantle dynamics. For now, the evidence suggests that the universe's tiny messengers are more powerful than they seem, quietly shaping the forces that make our planet tick. Next time you look up at the stars, think about this. The same cosmic processes that light up the night sky might be fueling the volcanoes beneath your feet. It's a wild, humbling thought, one that connects the vastness of the universe to the molten heart of Earth. So, what if the next supervolcano eruption isn't just about our planet's internal forces? Maybe, just maybe, it's the universe itself whispering, "I'm still here."